Okay, I'm sharing this. Just want to bring the experiment so we could talk about the theory of the experiment. For experiment 7, for experiment 7, we have 6 unknowns, just like the last experiment. We have 6 unknowns, and from these unknowns, using these unknowns, we are going to identify if they are monosaccharides, disaccharides, or polysaccharides. Carbohydrates, they can be classified to monosaccharides, disaccharides, or polysaccharides. One way to identify them, when you say carbohydrate, that means for every molecule for every carbon atom, you have one water molecule. That's for monosaccharides. So if you have C6H12O6, for 6 carbon, you get like 12 hydrogen and 6 oxygen. Monosaccharides, they can dimer and form disaccharides. I'm sorry. So when they form a dimer, if you get for a disaccharides, the general formula would be Cn+1 and then H2O, or number of hydrogen is not going to be double the number of carbon exactly. That's how you recognize it. Now, the difference between monosaccharides and polysaccharides based on the reactions that they are going through. So in the experiment, to identify each of the 6 unknowns, we are going to make sure that, first of all, one of them again is water, just like last experiment. If one of them is water, we have to have a reagent that all of the carbohydrates would give positive test. So if we have an unknown that is not carbohydrate, then it would be negative test. So we are going to do the Molish test. Molish test is general test for carbohydrates. So anything that would be positive, that is going to be carbohydrate. If anything gives you negative test result, is going to be water. So we know we can discriminate right away with one. Then we are going to do the Benedict test. Benedict test is going to is basically copper based, and the carbohydrates with the Benedict test, they are going to be is a reduction, oxidation reduction experiment. So copper 2+ is going to be reduced to copper 0, and then you see like copper 0 has a red color or cupric color. So if these reagents, they would give you red color, that means that is a positive test. Then we would do the Barefoot test. With the Barefoot test, we can identify the only compounds that were positive with the Benedict test. Then we would do the Barefoot test. And again, it's a type of oxidation reduction reaction. There is a table here. So if you're unknown, if it's positive with Molish test, that means is carbohydrate. If it's negative, it's going to be water. Benedict test, if it's positive, that means your carbohydrate is a monosaccharide. It could be glucose or fructose, or it could be lactose. And if it's negative, it's either disaccharide of sucrose or it could be starch. How would you find out if you have a starch or you have sucrose? If you do iodine test, the starch would be positive test with the iodine, and sucrose is going to be negative with the iodine test. So we are going to, at each step, we are separating some that is positive or negative, and then we are working with the ones that they were either positive or negative to discriminate, like to narrow down step by step. And at the end, we should be able to identify all 6 of them. So if you start even with the iodine test, you can discriminate, because only starch out of the 6 unknown that you have, only a starch is going to give positive test with the iodine. And then with the Molish test, it's going to be only water would be negative, everything else would be positive. So you identify like 2 of them right there with the 2 tests, and you can just continue with the other tests. With the Barefoot test, if it's positive, it's going to be glucose or fructose, but if it's negative, it's going to be lactose. And then the red color, or the positive test, that this was also a question on your quiz or pre-lab. A negative test, it may not be negative, it might be just slowly happening, and then this is going to be a faster reaction. So if it's fast reaction, is going to be fructose. And so if the color changes, you get like a red color right away, it's going to be fructose. But if it's the color change happens like slowly, then we know that is a glucose. What has Prelab questions? Do you have any questions? Any? Let me bring. I have to go back and forth to the chat, so you can type on the chat still. If you let me know if you have any questions about the prelabs. So if you have 6 carbon, 5 oxygen, this is going to be disaccharides. 7 carbon, 7 oxygen, this would be monosaccharides. With 12 carbon, 11 oxygen, disaccharides, and this is going to be C3O3 is going to be monosaccharides. And then you have this question here. The answer to that question was, this question is, the answer was actually glucose. And then I made a new question based on different observation, and that one would have been, the answer to that one would have been lactose, because it was negative test right here. Okay, procedure for the experiment. We are working with the strong acid, so I'm going to have to use gloves. Fume hood, unfortunately, is not working, and it's not the best and safest situation, but I try to be careful with inhaling these chemicals. And I'm going to have to go to the other screen just to show the video. And can you tell me, while I'm sharing the other screen, could you tell me if you can see the video also, or the video stops and only that screen it comes up? Can you tell me that, and using a chat, please? It stops. Okay, so I won't be able to do both. Okay, only one screen at a time. Okay, that's okay. So I'm going to have to depend on you to give me the procedure. So when I change the screen, if I stop sharing the other screen, then
Professor, I'm sorry to interrupt you, but there is a little button on the bottom right, so we can maximize to where we can watch the video, so you don't have to stop sharing the the presentation. So we can see both, except that the actual instructions are minimizing. But you can prioritize between screens, so you don't have to turn off the information for the experiment.
Okay. Or I can depend on you, right? You tell me what I need to add next. Okay. Very good. Very good. So you could see both. That's perfect. Okay. Well, it doesn't allow me to do it, but for you, it should allow you. It should allow you, but it doesn't allow me to do it. That's fine. First test. This is going to be knowledge test. So I'm going to stop sharing this. First, we're going to get 6 test tubes. Okay, so we are going to get 6 test tubes, right? And it's labeled A to F. I have 6 test tubes. Could you tell me my reagent? What should be my reagent? I'm adding. What would be my reagent? 2 milliliters of the reagent, smallish reagent. And how much of sulfuric acid? 4 milliliters of sulfuric acid and 2 milliliters of the smallish reagent. And what's the order? Which one is first? Smallish first. Okay. Should I add the unknowns first? Okay. How much of unknown? 3 milliliters of unknown. Okay, gotta do at the same time. I want to show you, this is qualitative analysis, okay? Because it's qualitative analysis, I'm going to measure 3 milliliters with 1 of A And I know that is 3 milliliters. So if that is 3 milliliters, I can now hold the test tube next to the other test tube and get 3 milliliters of. I don't have to use the graduate cylinder for that. And then I can just use this as a like comparing, just to eyeball 3 milliliters of C added to test tube C. I want to add D, so I hold the test tube D next to test tube A. Add 3 milliliters of D, E, and F. So I have one reference or blank cup. Okay. I have my unknowns added. So we are going to move down to the fume hood and add the molish reagent first. 2 milliliters of the molish reagent and 4 milliliters of the sulfuric acid. And the molish and sulfuric, they are in this fume hood. Hello. Is there any way that you could call someone to turn on the fume hoods for me? Maintenance, someone? The fume hoods are off.
I'm not sure how to do that.
Is there any number for facility? Someone?
I'm the only person.
Okay.
The only person you'd be able to call is security. I'm not sure who would do that.
Okay. Thank you.
I'm sorry.
That's it. Thank you so much. Okay. For molish reagent, I need 2 milliliters. Turn on the light so you could see it. 2 milliliters. I'm going to measure 1 squeeze, 4, 2, actually half each, 3 and 4. See which one is easier. So 2 milliliters of molish. Okay. 2 milliliters of molish to the next one. Adding 2 milliliters of molish to C. Two milliliters of molish to D. And E. And last one. Okay. What color do you expect with the sulfuric acid? What would be indication for positive test? You would get a purple color between the two layers. That indicates the purple color, okay? Purple. I normally follow the procedure like exactly the way it is, but because it's a qualitative analysis and the procedure and the fume hood is off at the time of the day, it should have been on, but because it's off, I'm going to minimize the usage of sulfuric acid. So I'm going to add enough until I see, I'm going to carefully add little by little, enough to see the purple color. If I see the purple color, that means I have carbohydrates. So I don't have to add more of sulfuric acid, because when I add the sulfuric acid to any of these test tubes that they are aqueous solution, is going to generate lots of heat, is a highly exothermic reaction. And because it's exothermic, I don't want to generate heat. I don't want these solutions to boil and it kind of spills out, foams out of the test tube. So what I'm going to do, I'm going to add enough until I see purple color. If I see purple color, I stop there. So it's not that I'm changing the procedure. It's just that I'm trying to minimize any accident or incident that it can concentrated sulfuric acid could cause now. But I can do this when there's a qualitative analysis. If it's quantitative, I have to be more careful with my measurements. So I'm going to bring the computers closer, change the angle so you could see better. Okay. You see it now, right? Okay. Do you see a purple color? Yes. Okay. So we can't stop there. I mean, I'm sure if I add 4 milliliters, you're going to get thicker layer here. At the same time, I might burn my pan because, or I could, I could get fumes of the acid, inhale it, and it's not safe for me. But as long as you see the purple color and make sure that purple color indication for carbohydrate, we know compound A is carbohydrate, or put a plus sign next to in your data sheet for A as a result of the Molish test. For second compound, which is B, I'm going to add sulfuric acid. Okay, compound B, I think I added enough, but I don't see any purple color. So I'm going to, at this point, that's one of the choices, to be water or no reaction, but I'm not going to draw a conclusion yet because it might change color later, or I might have something that it's more obvious than that. So undecided for B for now. Okay, what about C? You see the purple color for C? Yes, so C definitely is carbohydrate, positive for C. Adding sulfuric acid to D. That's D. Okay, very good. Positive for D. Compound E, or unknown E. Okay. Definitely purple for E. And last one. Compound F, also positive. Okay, so we are done with this part of the experiment. We have one of the one that did not show purple color, and that was compound B. B negative. Okay, we are done with one experiment, one set, and we are moving to the next one. Next would be, what's next one? What happened? Next one is the phonetic test. And for phonetic test, we are going to put 1 milliliter of unknown, 5 milliliter of the phonetic test. Okay, phonetic reagent, 1 and 5. And then we are going to need a hot water bath at this point. Because we need a hot water bath, I'm going to start the hot water bath. If you bring I'm just preparing hot water bath. This time, we have to, the tips are not clean. Yes.
Did you want me to try to help you turn them on? Do you know how to turn them on?
It's not from me. This room is centralized.
Oh, okay.
It's downstairs.
Oh, you turn it on downstairs?
Yes.
Okay. Okay, I'll try to turn it on for you.
Thank
I
you.
just don't have any keys or anything like that.
Okay.
Okay.
It would be nice if you find out and help. If not, it's fine.
All right.
Try to stay safe. Thank you. Okay. How many test tips do I need now? 5. Because I have to leave this in boiling water, I don't want to mix up my unknowns, so I have to actually label them each. Because first one, I didn't have to put in the boiling water. I could just put in a test tube rack with the labels. But when I put in the boiling water, I cannot take the chance. So which one I'm leaving out? Perfect. When you're working group of 2, one person takes care of labeling, the other one brings the chemicals, but it's okay. I guess I can handle it myself. Okay, we need 1 milliliter of the unknown, right? 1 milliliter of each unknown? 1 milliliter of each unknown. Again, I'm going to do the same. I'm going to measure 1 milliliter using graduate cylinder. I measure the 1 milliliter. A goes to A. I skip B. I'm going to C, hold it next to the test tube A, and put enough to make it 1 milliliter line that I have by comparison. Okay, C is done. D. E. And unknown F. They may not be exactly the same, but as long as you have enough for your reactants to show the color change, it should be fine. Again, it's qualitative analysis. This is not quantitative. It's quantitative. Okay, next we are adding 5 milliliters of the phonetic reagent to each one. So I'm going to take it to the fume hood. And add the 5 milliliters of the phonetic reagent. And we are going to place it in boiling water. One measure, 5 milliliters. And others, approximate. The first one you cannot approximate though. The first one you have to measure it so you have an idea. D. The only label that it might fall off is E. So if it does fall off, we know that was E, but I don't want, I hope that's the only one. Okay. Taking back, gonna cover this. No chemical reagent bottle should be left open. So we are going to take it back and place it in the hot water bath. Going to place this in hot water bath and count for 3 minutes. Let me know when is the minutes is up so I can check for color change. I change my gloves because they have changed color. Let me know when it's 3 minutes so I could take it out and check for you. I'm looking through my email. I'm looking for what something. Oh, nothing. Okay. I know it's not 3 minutes probably because I haven't got the notification from you. But when I see the red color appears, if I wait longer, it will be more red color. But for me, this is enough. Do you see the color of copper? The blue color has changed to like a brown residue. Is it clear? Yes? Okay. So E is positive. So you can mark E positive for the Benedict test. Okay. F is changing color. F is positive. I'm going to leave it in so you could see it better, but if you can't see already the color change, you could record it. Do you see the color change or you want me to place it back in the... Do you notice the color change? Put it back in the water bath, okay? So you could get more... If you compare these two, that's A, this is F, you see the color change. That's how when it's in the water next to A, I could see that the color has changed. Right? A, no. A has not, but F, yes. F would be positive, A would be negative. That's how I could like see that the color has changed. But if you hold it next to each other, it's much easier to see it. So for A, no change. A is negative. If I compare this one, see the color change? This was E, which you already marked positive. A is negative, E positive, F positive. Whatever this one is, it looks positive to me. That's C. C is positive, but I'm going to wait longer so you could see it better. Right now, you could see only by comparison, but C is positive. So I will show you them. E, no, this is E. And that's F. Both of them are positive. A was negative. Okay. That's C. This is C. If you hold next to A, that's A, this is C. C is also positive. So you see the label is C. C is positive, A is negative. And what about D? Negative. So A and D are negative. Okay? A and D are negative. Okay. So we are done with the genetic test now. Moving to the next test. Barefoot test. So 1 milliliter of anything that was positive in the test. So we are only working with 3 now. With the ones that they were positive, C, E, and F. C, E, and F. So I have to label 3 test tubes, C, E, and F. Okay. Going to label these just using the label here. And how much do we need? 1 milliliter of each. And then we add the reagent. Okay. 1 milliliter of each. For C, I'm going to add the C, 1 milliliter. Measure, 1 milliliter add. Then hold it next to E and add 1 milliliter of E. And add 1 milliliter of F. Then we are adding the reagent and we're placing in boiling water for, it says 10 minutes. We can actually stop when it's already red color or when we see the color change. We need 5 milliliters. Yes. Of the reagent? Yes. Okay. I'm going to measure 1 using graduate cylinder. 5 milliliters. I can pour. Sometimes it's hard to stop at 5, so you stop at 4.5 and add the rest drop by drop. This time it actually stopped at 5. We add 5 milliliters. Hold test tube E next to it. Add enough. And test tube F. Going to take it back to hot water bath. We place in hot water bath for as long as needed to see the color change. What does positive or color change here, what does it mean? Glucose or fructose, if it's positive? Okay, if it's positive, it's going to be glucose, and if it's negative, it would be lactose, okay? It looks like we are missing one reagent. Let me look for it. No, yeah. Okay, do you have any questions? This time C is not behaving. Label for C is falling off, so I'm going to have to hold it. Test tube folder, so the label doesn't fall off. Any questions? Well, okay. Perfect. Yes, we can actually use the time very efficiently. Perfect. So which ones were negative? A and D? It's good to smart. Yes. Smart students. Okay. A and D. Going to label A and D. So what are the specs for the iodine? Going to add 2 milliliters of A. Two milliliters of A to test tube A. And hold it. Now we're adding D to test tube D. If we add drop of iodine, find iodine and I bring it here. So that's A and D. D is blue color. Let's look at A, see what happens. Maybe both of them are. Okay. What's the conclusion? You have D and A. So D is going to be a starch. And if D is a starch, what is A? A would be sucrose. Okay. So we already have name for 3 of them, right? We already have name for 3. We have name for D, A, and also B. Very good. Very good. So we have A, B, and D already named. And what about color change here for C? I'm not sure if white background is going to show you or black background. You tell me. Definitely not the blue background, but do you see the red color at the bottom of the test tube? It's a red color precipitate. Yes? Okay. So as long as you see that red color precipitate, that's the copper that has precipitated. This is for C. So for C, we have the red color. There are two ways to see it. Either change the background or hold it to something that is negative, next to something that is negative. F is negative. So if you hold this, look at the bottom, both of them. For F is only blue clear solution, and C is milky. This is the Barefoot, yes. So F would be lactose. What about C? C, all you can say that is positive at this point. We don't know if it's fructose or glucose yet, but it's one of the two. What about E? This is E. Holding next to F again. Maybe a white background. You need to look at the bottom of the test tube. F is negative, but this is E. Do you see the red color, the bottom of the test tube? Yes? Okay. At the bottom of the test tube, there is a red color or red precipitate actually. And if I mix it, it becomes cloudy because you have the red particles in blue solution. It becomes very cloudy, and that is a positive test for E. So which two are left at this point? C and E. Very good. So we have a name for E as well. We have name for E. C is positive and E is positive for the Barefoot test. Yes. Okay. I need C and E. I take two test tubes. Label C and label. I'm going to add 1 milliliter of C. Measure 1 milliliter of C. And I hold the test tube next to C at 1 milliliter of E. So I have my last two, which is C and E. Unknown B was water, yes. Okay. So what do I need to add for C and E to find out if it's glucose or fructose? What's the reagent? Okay. And we're adding how much? 5 milliliter or 4? okay, we add 4 milliliters of the reagent to C and 4 milliliters to E. We are going to place in hot water bath. Fructose would be faster than glucose. So the one that changes color first is going to be fructose. So we are waiting just to see which one is going to change color first. If our reagent is working properly, they should both change color, but one much slower than the other one. The one that is faster is going to be fructose. And we can stop the reaction at that. Okay, I see a color change here. I don't know if you see or not. Going to bring it out. Do you see the color change? Yes? Okay. This color change is coming from E. So we have a name for unknown E at this point, right? Because C has not changed color yet. If we leave it there, it might happen, but very slowly. But since this is fast or faster in comparison, so we have fructose for E. Yes. Okay. Turn off the hot water bath. I like to, by the way, unplug the electronics always. Now I can answer your questions. Do you have any questions for this experiment? For those of you who took the quiz today, you got all multiple choice, right? Or you had one free response? All multiple choice? Okay. So I don't have to go in and grade it because the test originally had one free response and I had to go. So now you know, like the glucose, like when they test for the blood sugar is glucose, and when they're testing with very similar reagent to genetic test, and the copper, it's going to precipitate the color of the copper, or the amount of the color, or the magnitude of the copper that is produced is going to show how much it can be translated to how much sugar you contains. So it's just basically a simple reaction, but someone who was smart actually came up with a small machine that they can measure how much blood is a chemical reaction that is actually taking place on that little strip that you add a drop of blood. The last two was C and E, yes, for glucose and fructose. Item was for A and D. Thank you. Yes. Questions for me? No questions? Okay, perfect. The final, don't worry about final yet. When we are ready to take the final, then I will have 2 labs prior to the final. I will have a review and I tell you the type of questions. And if you're doing the pre-lab questions yourself, you don't get the answers from someone else. You actually read the experiment to get the pre-lab questions, you should be fine with them. And that data sheet also, just the pre-lab data sheet questions. It's very similar to those. May not be exact same, like the numbers that you had for significant figures, or, you know, if you get a table for, if you get a table like for last class, if it says you have unknown that it gives positive test with toluene reagent. If it's positive with toluene reagent, then your answer choices would be, is this aldehyde or it would be ketone? Is none of them? Then you can, you know, most likely it's going to be multiple choice. I don't like multiple choice questions, but I'm going to have to sit down and create multiple choice question for this. And for the lab, because it's not easy, you know, to ask good questions for multiple choice. Like, I want to see understanding of the experiment actually. So it shows better understanding if you write down your responses for me. I didn't have any screenshots today. I saw everyone is, they showed me a trick how to check if the students are actually being inactive. So they set it up with the time. So it's actually telling me if there's someone who just logged in and walked away from the experiment, or it's set up already on my computer. So I have less problems to worry about if the students are, I cannot tell you that. So that's the secret. And also, like, export the attendance to Excel sheet also is doable from the recording. So, okay, any questions? If you have a screenshot already, or if you want a screenshot, you can do the screenshot of this too. That's it. Take a screenshot of this, please. You can include the same folder that you have for, I'm going to, sorry, I'm hiding the labels. So that's E and this is C. And also this too. So you have the result. You have A and D, and you have C and E. You can take a screenshot of that. You don't have to take a screenshot of me. Yeah. I hope the labels show properly. Okay, A and D and C and E. A negative, I'm sorry, A negative for iodine and D positive for iodine. Here you have the okay. If you don't have questions, I'm going to stop the recording. Then I call for attendance, and then I will get back to answering your questions and looking at your data sheet if you have any questions for me. So let me stop the recording to call for attendance.